Hello again, everyone. Welcome to the second and the last Q&A session for today. We have with us our speakers, Ray and Michelle. Thank you so much, guys, for joining us. Again, a quick note for everybody attending the event. Please do add your questions in the Q&A section in the events page. So without further ado, let's get started with our first question. First question is for you, Michelle. Content security remains paramount in the streaming video. Can you talk about the security benefits of your approach and your recent integrations with Nagra and your approach to per session end-to-end content security in streaming video?
Great question. Before I answer, I thought I might give a little bit of context because our talks were very short and the Content Fabric Protocol is a pretty big idea. So the context behind this is that I myself and some of the rest of our team worked for many years in the traditional media supply chain of basically making file copies of everything and moving them around and then getting them out to the CDN. And you probably got from the beginning of my talk that was one of the big motivators for thinking about a dynamic, compositional, and decentralized kind of protocol that would replace those workflows. That's really what the Content Fabric Protocol is. And then, of course, it runs across a ever-growing network of nodes, right? Like other internet protocols do. It's application layer. So not trying to change TCP/IP, of course, but build on top of it. So with that kind of a mindset, then there are many parts of what has been done in isolated steps in media workflows that are rather fundamental. And one of those is, of course, content protection, right? And all of us are familiar with the fact that especially high value content has to be secured. There are lots of, I would call it sort of standard or typical ways of doing that, most of which involve trying to secure the environment, right? Because the content itself can't be intrinsically secured as it goes through all the chains of the workflow, especially as it crosses, different vendor environments. So one of the most basic ideas in the Fabric protocol is we're going to change that. We're going to turn it around. We're going to make the content the first-class citizen, and we're going to give it its own self-protection. And we do that through the cryptography of the protocol. And then that cryptography uses a new generation of crypto ideas and also even algorithms that come out of the blockchain world, which include trustless encryption technologies. And by trustless, I mean that the content itself can get encrypted from an owner to another party without having that re-encryption process actually reveal not only keys, but even give any control, if you will, to an intermediary process or to the infrastructure. And why does that matter? It means then the content itself can be self-protecting as it goes from one owner to another, right? Or from an owner to an authorized audience. And so getting back to the original question, so how does the Content Fabric do that? Well, one basic thing it does is provide for this kind of content owner-driven encryption and proxy re-encryption, which layers on top of that anytime something's served out to a recipient. And then that whole model basically verifies the identity of the participating parties through blockchain identities. And this is important because it gives you a way to make that universal through the whole chain from the source media to the output stream. And then the last point is you can put into the dynamic part of the protocol new features like forensic watermarking. And we recently did that with Nagra, which is one of the leading and sort of Hollywood approved technologies for what's called, AB or consumer scale streaming forensic watermarking. We did that. Here's the big point, right? If you watched the talk, you saw that just-in-time transcoding pipeline that's part of the Fabric protocol. We were able to incorporate the forensic watermarking directly into that as another feature. And then the mark itself is seeded with the unique, if you will, address of the user itself. For example, if that's a wallet address, like a blockchain wallet address, you end up with a unique seed combined with the algorithm itself. And together you end up with a AB segment pattern, which is generated by that just-in-time pipeline with the same scalability as the rest of what we do. So you keep the same efficiencies, you get the personalized mark, and you have it in a way that's really deterministically tied to the user session. And this kind of thing doesn't happen in the traditional, publish from the cloud to the CDN and then go to the consumer. There's many steps along that way, and it's very difficult today to be able to, shut down the leaking sessions, if you will. Whereas in this model, it's very direct, it's very deterministic. And then finally, you can shut down an individual session just by updating the policy for authorization that's held in the content object. So you have an instant off, right? That's one of the, I think, good examples of how a protocol like this changes what you can do. Right.
Got it. Makes sense. Thanks, Michelle. This next question is for you, Ray. Is there any active work going on to improve the inference performance?
Yeah, great question. So yeah, we are doing a lot of work to improve the overall performance of the real-time system, not only inference, but the overall end-to-end latency. Yeah, so I will divide them into maybe three categories. One is the model side. We're doing something on to improve the model performance. I think one thing is that we are training a model dedicated for the real-time case. It's a smaller model. We trade off some maybe some quality with the performance, but for real-time case, it should be good enough. Yeah. Second thing we are doing is we are improve the model architecture. So currently as I just presented in the talk, right? So our whole inference architecture is based on a pipeline style, but in some parts of our system is still not very pipeline, because for the lip sync model, it actually requires some context. So if we don't have enough context, the lip sync won't be looking good. So it has to wait for some data before it do the next inference. So yeah, so what we're doing is that we're trying to improve the model architectures and making it to be more like a streaming way. For example, maybe in the future, we don't need to augment the audio anymore. We just while we're streaming the audio, we just pass the audio stream to the model, and the model will produce the video stream in a streaming way. Yeah. A third part I would say is the whole architecture and the whole engineering work. For example, some native machine learning operators, they are probably not implemented in a good in a very optimal way, at least in our case. So we're trying to re-implement some machine learning operators ourselves, and maybe try to combine some of the machine operators into one to reduce the context switch, because GPU context switch is kind of expensive. So so in summary, we're doing a lot of work to improve the end-to-end performance of our system. Yeah.
That's really cool. So quick follow-up to that is, what is the current end-to-end perceived latency for the real-time avatar?
Yeah, in most cases, it's 2 to 3 seconds. But I think it's good enough for most cases. But still not good enough for very real-time cases. So I think our end goal is to reduce that latency to under 1 second. Yeah, and also when there are a lot of users using our system, that latency might be larger than 2 to 3 seconds. We're also trying to improve that as well. Yeah.
That's really interesting. Thanks. This question is for you, Michelle. With today's traditional media workflows, there are known scalability limits to delivering personalized content or video. Can you talk about the dynamics a bit more and how Alluvios approach is aimed to help address that?
Oh, yeah, for sure. So kind of referring back to my talk, the section on dynamic advertising, right? I'm going to use that as my example because personalization, right, is a broader context of the same idea. I think most people are familiar with the fact that the interstitial composition of content streams today is done in I would say a rather legacy manner that has stayed mostly the same, at least for 10 years or so since cloud media workflows got going. And the gist of it, of course, is that you have some kind of server-side stitcher driven by some kind of selecting algorithm that then the streaming pipeline hands off to pass what is otherwise packaged and transcoded content to the stitcher to then respond back with the stitched in stream, right? Problems with that, of course, are that if you're going to scale it, you can't do variants, unique content for each recipient. And vice versa, if you try to do something that's really personal, you can do it player side, right, or client side along the way, but you give up the mass scale. And a perfect example of that is Google AdWords, right? We all get that. There's a little bigger problem beyond the technology, which is it has grossly consolidated the stitching space to a few big players, right? Most of the digital ads are, really dictated by the big ad inserters, right? So the Fabric, being very different in terms of compositionality, frees you up from that problem. And the best way to understand it is to look at that visual pipeline in my talk, where you see that, the protocol is able, firstly, because of the content object structure, it's just fetching over the network what we call the base content parts. Those parts are one bit rate in video terms, plus the metadata parts and the code parts. It's just getting those, and it's never getting anything else. So you save the time, the storage, et cetera, in doing that. And then those are operated on in that pipeline way to transcode and produce the 2-second segment outputs in terms of streaming video. When you stitch in content in there, because the Fabric uses its own model, right? First of all, dynamic code. Secondly, the ability to retrieve parts that are content themselves and can be dynamically transcoded. It turns out that you can transcode unique content into each one of those outputs without losing those efficiencies, right? And that's the key thing. It's like you got yourself a real-time program that allows you to retrieve in the content and just in time transcode it into the stream and finally serve it out to the serving viewer. And so the scalability footprint on that is very close to as good as serving everybody the same set of content or ABR ladder. That changes things for content stitching. It makes it possible to do not just personalized ads, but to really even have personalized channels, for example. And today, one of the big applications of that, of course, in free and ad-supported channels is just that, being able to have really boutique content. And you saw the example in my talk with the weather case, for example.
Right. Thank you so much, Michelle. That makes sense. This next question is for you, Ray. How do you make sure that HeyGen's AI capability is not abused?
Yeah, that's a very, very, very good question. Yeah, because as you can see, like the avatar technology is very great, but also it's very risky. It can be used in some very bad purpose as well. But we definitely don't want our avatars be used in those areas, right? So I think we are trying to do a lot of stuff to prevent this. And first thing is like we dedicated document this in our policy and terms of service, saying that like some use cases are not permitted. For example, porn, like particular use case, drugs, sort of stuff. Yeah. And second, we are doing some automatic content moderations and also manual content moderations on our side. So if a user tries to abuse our system, for example, like he tries to maybe download a video from others and create an avatar using that video, that can be detected by our systems. We have a lot of detections. So those the errors I just mentioned in the policy that we can auto detect those. And also for celebrity, we also detect those. And in order to create avatar, we do require that person to give us a video consent to say that like they allow us to use their avatars to create use their video footage to create avatars. And we also have some detection on that to detect is it the consent video and the video footage used to create avatar are the same person, and they are actually speaking the statement I just mentioned. So and also like they sometimes they can try to fool us by just like replace the audio of the video. We can also detect those because we are doing lip sync. We can detect if the audio actually match their lips. Yeah, but like all the other like automatic detection, right? Those you cannot catch all the like use case all the like cases. So that's why we also have a manual moderation. So we have a moderation team behind the scene to try to look at the content because our detection will have a different state. One is definitely reject. Some are like suspicious. The moderation team needs to involve. So they will look at all those avatar videos and try to see if those are valid or not, and make decision. Yeah. Hope that will answer your question. Thanks.
Yes, that is completely rounded. Thank you, Ray. This next question is for you, Michelle, and it's a bit long question, so please.
Okay.
Just-in-time delivery and transcoding makes sense, but to avoid the compute costs of popular content, we will have to cache and store the transcoded data, right? Is this something that we will have to do as part of the pipeline or use CDN? And a small follow-up to that is, doesn't this cause the same file variant increase that you have talked about in your video?
Let me take the end of the question first. The short answer is no, but the real question is why? Why is this different than just the regular caching of all the things that everyone, basically caching everything that anyone's going to consume, right? The most important facet of the fabric that a lot. Did my bandwidth go? There we go. Can you hear me clearly?
Yes, we can.
Oh, okay, perfect. Let me start over my answer to that. Sorry, I had a little internet glitch there. So, into the question first. Why is this different in the end than just caching all the variants that everyone's going to consume, right? The most important thing about the Fabric protocol is, first I want to talk about the network consumption. If you think about the way we compose these variants today, we make everything that we think someone's going to consume and we push it on out to the edge, right? The question was about the storage, but the first order thing to like absorb in all this is that the fact that we do that means we spend the compute and we spend the network bandwidth in order to do that. And we do it with absolutely everything, right? That's not also to mention the ancillary services that you put around that in order to get all of that pre-made. And so the most important contribution, right, in terms of the resource footprint here is that nothing is ever made, right, and in turns cached, including transmitted over the network, composed into all of its various variants, whether they are bit rates or packaging standards, for example, or audio dub combinations, language combinations, thinking through, in the case of interactive apps, views, for example. None of those are ever done unless they're actually used by somebody, right? And then to your second point about the actual storage, right? Once somebody's consumed that, yes, the Fabric protocol caches what it's made. So yes, we do store that. But there's a really big difference from today's edge caches, which is that what we typically think about the necessary locality is very different. For example, Fabric nodes can basically cache on behalf of each other. And because the protocol is so responsive, and this is something that a lot of video people don't believe till they see it, but because it's so responsive, you also don't have to be as close to the end user in order to get high throughputs. For example, with HLS, we do 2 to 3 second, which some people call ultra low latency delivery with standard HLS off the fabric in live streaming. We don't have to, change the protocol in order to do that. That is using fragmented MP4 2-second segments, but people that are deeper into video transcoding and packaging know that most of the attempts to hit that in HTTP adaptive bitrate streaming are, making some pretty brute force changes to the HLS, the way the HLS protocol is done, and having other compromises in terms of the players. And the reason we hit those numbers is because the Fabric's pipeline is very responsive due to, how it's built. And therefore the clients get higher throughputs, the ABR ladders stay higher, and you don't have to be as close. So all of this ties back to your original question of, well, what really happens? Well, you save a ton of network bandwidth, you save a ton of compute doing this and all the ancillary stuff. And then finally, what you do cache, right, really doesn't have to be as local. Plus, you've got this ability to multi-purpose the caching from a set of peers. So I think these are all important to kind of come together to answer your question.
Yes, that does. Thank you so much, Michelle.
You're welcome.
We'll take one final question, and this is for Ray. What is the pricing model for real-time avatar?
Yeah, good question. So for the pricing model for the short answer is that we haven't finalized our pricing model yet, but we have some a rough ideas. Yeah. First thing is there could be different use cases for the real-time avatars. One is that maybe it will be just used for broadcasting, and the users will just use one session and broadcast to many users. But that session will be running maybe 24 hours, 7 days. Yeah. So for those one, I think we have we have some a pricing model maybe we can provide some monthly subscription for those models, so they don't need to worry about they are broadcasting for too long. Yeah. A second use case that we imagine is maybe some virtual assistant. They will provide this a virtual assistant to many users, maybe thousands or even tens of thousands of users. But usually those sessions are pretty short. They just ask some question and answer them. That's it. Yeah, for those use cases, I think pay as you go is better for them, because usually the sessions are pretty short. If we do a subscription, it will be super expensive for them. Yeah. That's it. Thanks.
Makes sense. Thanks for answering. Okay, so that was the final question for this Q&A session. Thank you once again, Ray and Michelle, for joining us, taking the time, and engaging us in this Q&A session. This was very informative. Okay, we now have a live panel coming up next, so please stay tuned. Thank you.